Up to this point, what we've covered in terms of properties of triangles and lines, two of the key ones that we've covered so far is we've covered bisectors, so a line going from a vertex in a triangle to the side opposite it, which cuts it in half, but not necessarily at a right angle. We've also looked at altitudes of triangle, which is a line that goes from a vertex to the side opposite, cuts it at a right angle, and is perpendicular to it, but does not necessarily cut it in half. We're going to combine those two general ideas today, and what we're going to look at in this video is we're going to look at perpendicular bisectors. So we're going to look at lines that cut other lines in half at a right angle. So we're going to combine the two key points of those two thoughts of triangles. So it could look something like this. Now we mentioned it about it being triangles. So this is a setup in a triangle. We've got the line CD cutting the line AB in half, and we could tell it cuts it in half because both sides here are the same as indicated by the little marks, and it cuts it at a right angle, so it's perpendicular to it. However, it's not just limited to triangles. We could have a general case where we've just got a line AB, and we're told the line CD is a perpendicular bisector to that line. So it doesn't have to be set up in a triangle like the other two scenarios we were talking about. But it still has those two key properties. It cuts it exactly in half here. Both of these are the same. And it cuts it at a right angle. So again, some of the key properties we're talking about earlier on within our calculations come into play. Calculating the midpoint of this line, calculating the gradient of this one using the property m1 times m2 equals -1. If we were asked to calculate the equation of this line, we'd have to combine both of those. Now, if we were ever asked to calculate the equation of the perpendicular bisector, again, there's a few standard steps you should really follow. And as we've talked about every single time, the first step should always be to sketch it. Give yourself a sketch and visualize the scenario and the problem in front of you. Once you've done that, the second thing you should then do is calculate the midpoint of the line. So in this case, for both of these scenarios here, I would calculate the midpoint of the line AB. What this would give me is the point located exactly there, which would be the point of intersection between the two lines, which will come in very, very handy. The next thing we then have to calculate is the gradient of the line we know both points on, so the gradient of the line AB. Once we've done that, we can then use the m1 times m2 equals -1 property, where we take our gradient AB and substitute that in. And this property here, the m2 it gives me, will be the gradient of the perpendicular bisector. So it will give me the gradient of that line that I'm after calculating. Once I've done that, I've got the two properties that I need to know for a straight line. I've got the gradient, I've got a point somewhere on the line. I can now use both of those to then get the equation of the perpendicular bisector. So the equation of CD. So I could calculate the equation of CD in this case. It's a 5-step process, but this is the standard process that we want to use when we're finding the equation of a perpendicular bisector. Best way again to demonstrate this is with an example. So imagine I've got 2 points. I'm going to call it the point A, which is -2, 1, and the point B, which I'm going to give you as the coordinate 4, 7. And what I want for these is I want the equation of the perpendicular bisector. Okay. Now again, follow those standard steps in that standard process for finding it. The first thing, do a sketch. So imagine I've got my 2 points, my point A and my point B. I've got my straight line there and I've got my sketch. So there's A and there's B. And I want the perpendicular bisector, so I know it's a line that's going to cut it exactly in half. I can indicate that by doing there, and those are equal points. From the point C to D, I'm just going to name it as those, and I know it's perpendicular to that. So that's the scenario I want, and this is the equation of the line I need here. First step is we have to find the midpoint. Okay, so we have to find this point here where it cuts the line. So in order to do that, we find the average of both of these parts here. So we find the average of the centre of the two x's, average of the centre of the two y's. So in this case, I would do -2 plus 4, divide that by 2 for the x coordinate, and I'd do 1 plus 7, divide that by 2, and that will give me the y part of the coordinate. So negative 2 plus 4 gives me 2. Divide that by 2 and I get 1. 1 plus 7 is 8. Divide that by 2 and I get 4. So I know the coordinate here of CD cutting AB or intersecting the line AB is at 1, 4. So I've got one part of my equation. Now all I need is the gradient. Well, the first thing I have to calculate is the gradient of the line AB. If I get that, I can use this property here of perpendicular lines to get the gradient I'm after. So again, we use our general formula for the gradient, y2 minus y1 over x2 minus x1. Substitute in the two coordinates, 7 take away 1 over 4 take away negative 2, and then it's just a case of simplifying. 7 take away 1 is 6. 4 take away negative 2, minus minus becomes a plus. 4 plus 2 is 6. So it's 6 divided by 6, which is 1. We then use the property m1 times m2 equals negative 1. That'll give me the gradient of my line CD. I know what m1 is because I've just calculated it here. So I can say that 1 times m2 equals negative 1. So our perpendicular gradient has to be the negative 1. Now we've got the two key things we need for the equation of a straight line. We've got a point somewhere on the line and we've got the gradient of that line. We substitute it in. So we use our y minus b equals mx minus a formula again, but we have to use this midpoint. So in this case it's going to be y minus 4 equals negative 1 our gradient, bracket x minus 1. Multiply it out, y take away 4 equals negative x plus 1. And again, we've got the two versions or the two forms of the equation of the straight line we can use. We could have it written as y equals negative x plus 5 or y plus x minus 5 equals 0. Again, both versions mean the same thing. If they're asking for a specific format, stick with it. If not, you've got two different variants of the same equation right there. Again, it's a very straightforward set of steps for calculating this. Follow them every single time. So start with a sketch, get your midpoint, get your gradient, use the gradient formula or the m1 times m2 equals negative 1 to get your second gradient and then plug it all in, and that's you got your equation of your straight line.